Howdy, it's me, friendly neighborhood calculus teacher, back with another AP review video. This time we're talking about topic 2. This topic is on linear motion. So linear motion, we studied like in 3 chunks throughout the class. 2 of the big chunks were about differentiation, where we learned about the relationship between the first derivative of position, velocity, second derivative of position, acceleration, which is the same thing as the first derivative of velocity. We talked about average velocity, average acceleration, directions, all that stuff. Similar to the type 1 problems on rate and accumulation, these problems can be given as equations, as tables, and as graphs also. And when that happens, you have slightly different skills. So make sure you try to get in a variety of practice on these. 2 of the most confusing ideas that you want to pay careful attention to is speeding up and slowing down. So make sure you know exactly what that means before you try to answer a question. If you don't know exactly what that means, it's going to be something worth reviewing. Briefly, in order to be speeding up, you need acceleration and velocity in the same direction, and you'll have decreasing speed when acceleration and velocity are in opposite directions. The second really confusing idea is distance versus displacement. Remember that as we can move in a couple of different directions, our final position may not match our distance traveled. We could start in the same point, walk 1,000 miles and return to our same point, and our displacement would be 0, which is not the same thing as the distance. So be very careful with that. Without further ado, here is the problem I will go through. As per usual, I'll leave it up here for you to try, and then assume that you have looked at it before I go through my scoring or my work in reasoning, and then the scoring guidelines. So this one is a non-calculator question. Okay, welcome back, assuming you did your work. Part A, try to figure out when the particle is moving left. Hopefully you remembered that the particle P, there's 2 particles here. Particle P is moving left when the velocity of particle P is negative. The velocity of particle P represents the first derivative of the x sub P function. So we actually have to take that derivative, and in order to take that derivative, we need to use the natural log shortcut as well as the chain rule. Please remember, when you're differentiating, all shortcuts are in place. Always consider the product rule, always consider the quotient rule, always consider the chain rule, and finally, always consider implicit differentiation when the derivative you're taking does not match the variable you're taking the derivative of. But we need to know at what time this happens, so we would set that derivative equal to 0. The denominator has no real solutions. The numerator has a solution at 1. And then we would consider the interval from 0 to 1 and 1 to 8. Between 0 and 1, we can determine that the value of the velocity is negative. That means we're moving left. Moving on to part B. The particles will travel in the same direction when they have the same sign. So in part A, we determine that from 0 to 1, the particle is moving left, and from 1 to 8, the particle is moving right. That's for particle P. Particle Q, however, we need to go to the equation for particle Q. This time we notice that we have the velocity. So we don't want to take the derivative at all. What we want to do is consider, okay, when does this velocity equal 0? Because that means the particle is at rest. And when the particle is at rest, that means that it could change direction. So from 0 to 3, we can determine that the sign of the velocity for particle Q is is positive. From 3 to 5, sign of the velocity is negative. 5 to 8, sign of the velocity is positive. And then we match up 1 to 3, both particles are moving right. 3 to 5, both particles are moving left. Part D, what is the position when particle Q changes direction for the first time? So we've already noted in I skipped part C. Shame on me. Part C. The acceleration at 2 means we need the derivative of the velocity of particle q. I got -4 for that. Then, follow-up question. Always remember to read to make sure you have checked the follow-up question, if there is one. Increasing or decreasing speed. We already know that at 2, the acceleration is negative, so the acceleration is to the left. And previously, in part B, we determined that the velocity is to the right, because 2 is between 0 and 3. That means the speed is decreasing or slowing down. Both phrases are used interchangeably. Now we can go to part D. Okay, for part D, we need the position of particle Q the first time the particle changes direction. We reference part B similar to how in part B we referenced part A. So if you've already done the work, you don't have to repeat the work, but it's a good idea to point the reader in the right direction so they score your work correctly. So 3 and 5 is where the particle changes direction. The first time we change direction, if we start out at 0, first time is 3. So we would like the position at 3. We don't have a position function. We can actually get a position function, but let's say we couldn't get a position function. We could still integrate 0 to 3. We just have to use our calculator. This is unfortunately non-calculator. So we know that we must use an antiderivative for v sub q of t. And you have to remember that the starting position, the position at time 0 is 5. So you don't have to write exactly this phrase here, this statement, this notation, but you're going to need an integral, and you're definitely going to need to add 5 again. So I find my antiderivatives with a bunch of power function shortcuts, evaluate at 3, evaluate at 0, subtract, add 5, we get 23. Turning our attention to the scoring guidelines, they look like this. So as always, the free response is 9 points. You'll notice for part A, you get a point for the first derivative, and you get a point for the interval. The text here is not necessary. Actually, I think the text is necessary in this case. Regardless, you want to show your first derivative. You want to show how you get 1, not in super detail. And then you want to note that the velocity is negative, which means particle P is moving left. Now for part B, you'll notice that they have created a sign chart. A sign chart to a grader is like this. They don't see it at all. They don't score it at all. What you need to do is take time to analyze what the sign chart tells you. So if you determine 0 to 1, the velocity for P is negative, 1 to 8, positive, you need to discuss that in some fashion, like is pictured here. Similarly, for particle Q, 0 to 3 is positive, 3 to 5 is negative, 5 to 8 is positive. They're not going to look at a sign chart. What they are going to look at is your analysis of the sign chart. You need to explain what the sign chart means. So, slightly different answer from what I had. 1 to 3 and 5 to 8, same sign, because the velocity of particle P, and which is the first derivative of particle P's position, and the velocity of particle Q have the same sign. Both of those are going to be fine to answer this question. Part C, we get a point for determining -4. Now, in order to get -4, you're going to need correct notation and write down the first derivative. Again, this is non-calculator. If you're going to be taking a derivative, you want to write your derivative. If you're going to be doing an antiderivative, you want to write your antiderivative. If it's calculator, you don't have to do those things. You can just go right to your calculator. You just say, I'm taking the derivative of this. And then pretty much the same thing that I wrote. At t equals 2, the speed of the particle is decreasing because velocity and acceleration have opposite signs. Particle Q is very close to what I have. I don't want to spend a whole lot here. There are 3 points. 1 point is for having the 1/3 t cubed minus 4t squared plus 15t. 1 point is for, in some fashion, adding 5. So you have 3 versions here. You have my version, and then, of course, the final answer, 23, which brings us to the end of topic 2. Hopefully you enjoyed that. See you in a future topic. Thanks.